Welcome back to Cyber Implant Presentation Part 2, the guide frame fabrication. Several steps are necessary to fabricate a CT-based guide frame. First, we need to use a CyberBite. Then we need to send the patient for a scan. Then we'll show you how to use a CyberJig, then the Cyber Planner, and finally the fabrication of a frame. The CyberBite. The CyberBite is a tool which allows the acquisition of a patient's bite. There is a little nylon mesh, and we actually have a registration of a bite using a heavy body silicone. You will notice that there are 5 black markers on the bite, and there is also a device which is made of plastic and it can be used as a handle, and which has also little points in a material which is radio opaque. We call that the pyramid because those points correspond at the summit of a pyramid. The pyramid is attached to the bite, and you will notice that there are different configurations. The pyramid can be either in the front of the bite or on the side. During the scanning acquisition, the pyramid has to be completely embedded into the scan. But some modern or smaller CT scan available in dental offices are now using smaller field of view, and the side mount of the pyramid is used for those cases. So when the CyberBite is placed in the patients, it will define a coordinate system for the patient. So all the patient's parts will be in the XYZ coordinate defined as it is on the schematic. And the same coordinate system will be transferred for the CT scan and also the stone cast, as well as the implant placement and the milling for the guide frame. Now, when we send a patient to the CT scan, there is no need for a radiographic appliance, which requires some time. The DICOM data will have a coordinate system, and I will demonstrate how this is done a little later. The CyberJig is a very precise articulator or occludator. It's a hinge articulator, and you can see that the CyberBite is actually engaged in it, and this precision device is used to mount the articulator or the cast into the same coordinate system as the patient. Now, the cast which is mounted will be called zero mounting because it belongs to the same coordinate system in the same position as the patient. Now, you will notice also that the bite support as well as the side arm in stainless steel can be removed, and then this is a very inexpensive and very high precision articulator which can be used at low cost by the lab and the dentist. It is also important to know that it is so precise that a lab can transfer a case without the articulator. It will fit in the same relation any other articulator. The CyberJig has accessories One is a mounting table allowing to mount dentures or teeth or partial dentures. The other one is a tray, which is a duplicating tray in the zero position. And you have also disposable plastic mount, which are very inexpensive. For partially dentureless patients, we recommend that you take 2 impressions of the patient, and you also take the bite registration with a partial denture. And you can mount, uh, putting the plaster from the top, you can mount both models in the same coordinate system and the same relationship, and you have 2 zero-mounted models. For the fully edentulous patient, we don't feel that a impression of the edentulous ridge is precise enough to fabricate a guide frame. So what we call, we do a functional impression, meaning that we are going to use the denture in the process. So the bite is taken or registered with the denture in place in the patient's mouth. Then the denture is reproduced with a alginate impression outside of the mouth. And that is really the important feature of the functional impression. We put a putty inside the denture, and the inside the denture is not the representation of the edentulous ridge. It is the edentulous ridge under pressure under the denture. And that is really what we want to achieve. Now, we can mount then the cast of the denture into the jig, and then we can do a zero mounting of the jaw. And we repeat the same using the denture into the jig, using the bite, and the putty is zero mounted as well. And this is how we use the duplicating tray. The putty is duplicated in plaster into alginate here. And we can then duplicate that in plaster. And so we end up with 2 models. On the left, you have the zero-mounted denture, and then you have on the right the zero-mounted functional edentulous ridge, which is given by the denture under pressure on the mucosa. So all the casts are going to be optically scanned, and they will be aligned according to the coordinate system. So when they are imported into the software, they automatically align with the CT scan. The CyberPlanner is a very friendly software. It allows the automatic import and orientation of the scan data. The surface scans and the wax-up are also automatically oriented. It allows the virtual wax-up, collision prevention, as well as extraction or bone graft or alveoloplasty. It has an integrated guide number and then has a sharing with colleague features. Export of the implant location or the guide number cylinders allows the frame milling or printing, as well as the analog placement in the cast. Here is an example of a scan which has all the markings from the bite and from the pyramid. And the geometry of the pyramids and the markers are embedded in the software. It's something that you may not have to deal with directly, but it is important that you understand how it works. So the scan is imported, as you see on the right hand side, but it's not in a good position. It's just a random position. And the software is going to replace the scan according to the embedded native file, which has all those characteristics. The software automatically identifies the flat portion of the markers which are embedded in the gut of the software and compare it to the flat surfaces of the CT scan from the pyramid and from the bite. And after a calculation, the recognition is achieved, and the CT scan is moved in the zero position. So now the scan has been moved into the zero position. We can start the planning. So here is the planning. We can place a guide number cylinder, and the each portion of the guide number cylinder is adjustable, orientable, and the position of the B point and A point are exported as guide number cylinder coordinates, and all that from the XYZ axis and the zero. The model or the cast are optically scanned and oriented in the same coordinate system by cyber implant. The wax up also can be scanned and oriented in the same way. So when they are imported into the software, they will align automatically with the CT scan. Here's an example of the windows variable into not the newest version, but a previous version of the software. Here's an example on how everything works. So we are selecting a sagittal section, and we are going to place an implant. So we have a surface scan which appears as a blue line. We have also the wax up which appears as a green line because they all match into the same coordinate system. Then we can import a generic guide number cylinder where we see the pink portion of the gingiva. We have the bone portion in yellow, and then we can rotate pretty much everything. You see on top a chimney to see the emergence profile. So we can adjust the position, the shape of the guide number cylinder. And remember, it is not an implant. It is more like an osteotomy that you are placing into the jaw. The guide number cylinder is calculated, or the guide number is calculated for you and appears in a proper color. And for those who want to verify collision, we have also a collision cylinder which can be adjusted inside. There are some colleagues who don't like computers or don't have the time. So for those, we have what we call the assisted planning. So they still can have access to the technology without spending their time on the computer. There is a request form, and they have a way to make their requests. This is an example of a request for a first lower left molar as an implant. So when we receive the CT scan, we will generate a section on a virtual image or on a paper image, and we will place the gingiva, the cross section of the jaw, and a ruler. So with this in mind, the clinician will be able to mark the of the extent of the guide number cylinder, and will send that to us. We will duplicate the request with a guide number cylinder, and we will send it for approval. And when the signature is provided, we will start the construction of the guide frame for them. So this is the first way to do the guide frame, which is the milling. So the guide number cylinder coordinates are exported to us, and we fabricate a triad a frame, which is on the zero-mounted cast from the patient. Then we simply place the model into a 5-axis milling machine, which knows the zero of the patient, and cavities or nests are milled, and those are preset to receive the guides. This is an example of a mill frame. We can also have a 3D printing for the frame. Now, the software allows us to do all that preparation of the frame, and we will provide a 24-hour service for printing. The printing we are using is a state-of-the-art printer, which allows to produce a frame which can be sterilized with steam in the office. These are the steps used by the software. The first thing is that we calculate, or the software calculate the draw of the cast, and you can see in red all the marks which are undercut. Then we place little wire clasp on those on the teeth, and we join the cast with different other wires to rigidify the frame. And this is exported, and we have an example of a case here, which has the cavity ready to receive a guide with a proper index to allow a certain guide number. Now, for the fabrication of the narrow diameter implant in the anterior region, we are mounting the guides above the occlusal plane. So we need to use longer drills, and this works well in the anterior region, obviously not in the posterior. We have also a very efficient guide frame fixation system. We are supporting a screw attachment which allows the placement or the adjustment of the pressure onto the dental ridge. We also have a feature of placing analogs into the models. To avoid a breakage, we like to duplicate the model in epoxy, and we are then placing cavities for the analog with the milling machine. Remember, this is a zero-mounted cast, so we know exactly where the implant coordinates are, and we can place and glue analogs, allowing the fabrication of a prosthesis for immediate load. Finally, we support a model-based guide frame, and these are the step-by-step to achieve that. Very often, we have a situation where we need to have a guide frame fabricated in record time due to an emergency, or we have a CT scan or not, but we have the information of the available bone from other source, and we need to do a frame without the software. In order to place implant well without the software, we need to respect a certain spacing between the implants. 7 millimeter is the usual rule of thumb. If we place implant closer, we get in trouble. So we have 3 rulers, one for single unit, one for bridge work, and one for edentulous jaw for hybrids. And this is how we use it. So we place the ruler in the edentulous jaw, and then we slide it to have the desired space, and then we mark the model with a pencil. Then we make a hole using a 2 millimeter twist drill on the mark, and the orientation is based on the available diagnosis, the cast, the x-rays available, or the palpation record. And then we have one guide holder pin that you can see on the top, and this is a medium diameter and a large diameter. We place inside the pin a guide holder sleeve, and which has all the features of the nest cavity, which are milled into the frame, and we process these in place in the lab using Luxotherm and Triad. The frame and the supply comes back to the dentist, the surgeon, with a very simplified preparation for the surgery. It has all the drilling sequence recommended for that particular implant he plans to use. Preparation of the surgery is very simple. There are components which are steam sterilized in the office, such as the drill, and we provide the surgeon with a drill holder. The frames are placed in a pouch and steam sterilized. Notice that we can steam sterilize both the 3D printed frames as well as the milled frames and the lab fabricated frames. The other part of the kit is delivered sterile, and that part is disposable. The pouch can be opened. They are double bagged, so they can be dropped on a surgical tray, and there is a series of guide with a guard carrier as well as the punch. You'll notice that there is a number on each guide, which is matching the order of the drills, and which have a number also on the side. So usually you cannot make an error. Thank you very much for your time. I invite you to watch now the video number 3.